So the new part we will start today, we will start with this example. So this example says we need to find the molar volume. Again, molar volume, when you hear this word, so this is molar volume, which is volume divided by number of moles. We need to find molar volume for normal pentane at 100 degrees Celsius, 100 kilopascal, using Peng-Robinson equation. Here he said the value of a parameter for Peng-Robinson equation is this one, and it's important to see the units here. Pascal, centimeter to the power 6 per mole square. And then we have the value of B is this value, centimeter cube per mole. So this one is just straightforward. We have value of A, we have value of B, just we need to substitute in the equation to find the molar volume. But before we start, do you remember how many value of the molar volumes we can get in this equation? 3 values. This is why it's called the cubic equation of a state. We have 3 values for the molar volume. The lowest one represents liquid or vapor, liquid, and the one in the middle, usually neglect, this is unstable, and the largest one for which phase? Vapor phase. Okay. Here in general, he said we need to find the molar volume. He didn't mention liquid or vapor, so we need to just find the 3 values we have. So how we can solve this one? So this is the equation, Peng-Robinson equation, the general form of it. Okay. What are the parameters we have? So A is given. This is value of A, 2.417 times 10 to the power 12 Pascal, centimeter to the power 6 divided by mole square. Just this is the first given we have. We have B, the second parameter. This one is 90.18 centimeter cube per mole. The temperature is 100 degrees Celsius. Should we leave it Celsius? No, we don't use Celsius, so this one should be Kelvin. So plus 273. So this will be 373 Kelvin. Pressure, we have 100 kilopascal. Again, kilopascal, this is the pressure units in SI system? No. What is the pressure in SI system? Pascal. So this one should be 100 times 10 to the power 3 Pascal. Then molar volume, this is what we need to find. The only remaining thing is R. If you remember, we have a slide explain to you the different values of R. So one of them is this one, 8.314 joule per mole Kelvin. And joule, this one is Pascal meter cube. But again, we need to check the consistency of the units we have. If we use R, 8.314, so the volume units in this R is meter cube, right? Because we have joule, SI system. But the value of A, we have the units in centimeter, right? Even in B here, we have centimeter cube. So here we have inconsistency of the units. So either you convert A and B from centimeter to meter, or the easiest, just convert R from Pascal meter cube, which is joule, to Pascal centimeter cube. So if we did this, so we have this one here, the value of R that we will use, this will be 8.314 times 10 to the power 6. This will be Pascal centimeter cube per mole Kelvin. Just finally check on the units. So we have, here we have Pascal, SI system, here we have Pascal. These are consistent. Here we have temperature in Kelvin, the temperature in Kelvin. We have this one in mole, here we have mole, here we have mole. Then here we have centimeter cube, here we have centimeter, here we have centimeter. So now we have consistency in the units we have. Okay, not all of them in the same system of units, as we said, not all of them SI, but we have this homogeneity of the equation. Clear? Then we have 2 options. Put this equation in your calculator and your equation can do this, or you can solve it in Desmos. Let me. So Desmos, basically, this is the website. By the way, this website, it was recommended from one of the students previous semester to me. So basically you can put the given you have. So you introduce the value of pressure in Pascal, the temperature in Kelvin, the value of R in the, after converging its units, the value of A, value of B, and then put van der Waal equation. So directly it will make this plot for you. But now we need to know what is the molar value at this pressure, 100 kilopascal, right? So just at the end, you can say y-axis, I need it to be as pressure. So it will show this one to you. So this is the, like, the red line or the red curve. This is the plots of the Ping-Robinson equation. The blue one here, this is the horizontal line that represents the pressure that you have. Okay, so here we can just make zoom to see that here we have two intersections. Okay, so this is the first one. So the first one, it says we have 133 centimeter cube per mole. This will be the first value of the volume. And this will be for liquid or vapor? Liquid. Then we have the second one, 476 centimeter cube per mole. And this is nothing. This is unstable. Then we need to go to the last intersection here. Just click the point. And this will be 30,311 centimeter cube per minute. So these are the third value, or this is the molar value for the vapor phase. Clear? Any questions? So again, when you use the equation, the most critical point here, just make sure of the consistency of the units, because you have units of A, B, you have pressure, and then you have R. Just make sure the units we have are consistent. Okay? Let's put it here. Let's have an example. Now let's do the following. Let's assume every three of you can work as a group.